Given the frequency distribution and probability distribution, showing the number of classes a sample of CCC students are taking this semester. So on the left-hand side, we have the frequency distribution, and on the right-hand side, the probability distribution. So the random variable x is just the number of classes a student is taking, 1 through 6. The frequency of 6 says that there were 6 students that said they're taking 1 class. When you add the frequencies up, you get 150. So 6 out of 150 gave us 0.04. And this goes back to the previous video of finding this probability distribution, so I'm not going to explain that any further. Okay, so given those two distributions, two events are disjoint or mutually exclusive if they have no outcomes in common or can never occur at the same time. So in this example, can a student take 1 and 2 classes at the same time? So when a student from the sample was asked, how many classes do you take? Could they say they take 1 and 2 classes? Well, no. They would only say they're taking the number of classes that they're taking. Okay, so a student may say they take 1 class, but they're not going to, that same student is not going to also say they're taking 2 classes. Okay, so no, these events are disjoint or mutually exclusive. Okay, so if we randomly select one student, find the probability that x equals 1. So if we choose one student, the probability that they said that the student said they're taking 1 class, well, the probability that x equals 1 is 0.04, which remember was 6 out of 150. Okay, so 6 out of 150, that's as a fraction, and then the probability as a decimal will be 0.040. Okay, the probability that x equals 2. So the probability that a student said they're taking 2 classes, well, that's 0.093, which was 14 out of 150. Okay, the probability that x equals 1 and x equals 2. Now you have to pay attention here. Remember that we're choosing only one student. So when you choose one student, is that student going to say they took 1 and 2 classes? Well, that's what we just set up here in the first question. They're not going to say they take 1 and 2 classes at the same time. So those were disjoint events. So the probability would be 0. It's an impossible event to say that the student is taking 1 and 2 classes at the same time. Now what about the probability of x equals 1 or x equals 2? So now when you select one student, what's the probability they said they're going to take 1 or 2 classes? Well, 1 or 2 classes means that x could have been 1 or 2. So you would add those two probabilities together. So that would be the 0.040 plus 0.093, which is 0.133. Okay, so that brings us to the addition rule for any events. The probability of A or B. So A is one event, B is another event. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So you have each of their individual probabilities. So if we select one student, let's just say we're looking at the x equals 1 or x equals 2. The probability of A, so the probability of choosing a student that said they take 1 class is 0.04, plus the probability of B. We'll say that event B is that a student said they're taking 2 classes. So we're going to add 0.093 And then you would subtract the probability of A and B. So a student saying they're taking 1 and 2 classes, which we already said was 0. So technically, you would take the 0.04 plus 0.093 minus 0, and then add those to get 0.133. Okay, so the last couple examples here. If you select one student, the probability that x equals 4. If you go back up, x equals 4 is 0.467. And then the probability that x is greater than 4. Well, greater than 4 is 5 or 6. So you would add 5 or 6 together. So 0.213 plus 0.067, which is 0.28. And then x equals 3 or x equals 4, you would add 3, which is 0.12 plus 0.467. You would add those to get 0.587. And in each of those cases, notice that the probability of A and B would be 0 each time, because the x values are mutually exclusive from each other. They're disjoint. They cannot occur at the same time.